Good morning, dear students. In our previous lecture, we have studied regarding EMF of a cell, reversible cell and irreversible cell. So next one is the reversible electrodes. As we already studied regarding reversible cells are made up of two half cells which are containing reversible electrodes. Reversible electrodes are what? These are the electrodes at which the reaction with respect to the ion that will be reversible. It can take place in either forward direction as well as in the backward direction. So we will study different type of reversible electrodes in today's lecture. The first one is the metal ion electrodes. The second one is the amalgam electrodes. The third one is the gas electrodes. The fourth one is the metal insoluble salt anion electrodes, and fifth one is the oxidation-reduction electrodes. So first one is the metal ion electrodes. In this type of electrode, we dip a metal strip in a solution of the metal ion. For example, in this figure we can see the copper metal has been dipped in the solution of copper sulfate. Similarly, zinc metal that has been dipped into the solution of zinc sulfate. So these are the metal ion electrodes. At these electrodes, the reaction can be either oxidation or either reduction depending upon to which electrode we are connecting these electrodes. So these can act as either anode as well as cathode, and these are the reversible electrodes. Now next one is the amalgam electrode. In case of active metal like sodium potassium, the simple metal ion electrode, they are not possible because they are easily attacked by the water in their aqueous solution. So in these cases, the activities of these electrodes are reduced by amalgamation. So such type of electrode in which the metal is converted to the metal amalgam and it is further in the contact with the solution of its ions, that is known as amalgam electrodes. For example, we can take here sodium that is in contact, sodium is amalgamated and it is contact with the solution of ions of Na+. So what is the benefit of amalgamation here? By amalgamation, first one is the activity of metal is reduced. Second one, the impurities are diluted by amalgamation. And third one is the equilibrium is attained quickly on amalgamation. So these are the benefit of amalgamation, and amalgam electrodes are the electrodes for the active metals. Now next case is the gas electrodes. In case of gas electrode, we can take the reference electrode as an example, which is standard hydrogen electrode. This standard hydrogen electrode is generally used as a reference electrode to calculate the electrode potentials of other electrodes. Now in this type of electrode, what is done? An active gas is bubbled over inert metal foil dipped into the solution containing ions of the gas. So here hydrogen gas that is bubbled over the platinum foil. This platinum foil is dipped in the 1 molar solution of HCl. So it can act as a reversible electrode. So different type of possibilities are there. It can act as anode as well as cathode. When it is acting as anode, this reaction will take place. Hydrogen will release 2 electrons to convert into H+ ion. And when it is acting as cathode, the hydrogen ion present in the solution, they will take up the electron and they will produce the hydrogen gas. So this reaction, this electrode is reversible with respect to the reaction with the ions, and it will be known as standard hydrogen electrode because it is working at standard condition. Here the pressure of hydrogen gas is 1 atmosphere and concentration of HCl solution taken is 1 molar. Now next one is the metal insoluble salt anion electrode. As the name indicating, in this case, the metal is first one in contact with the metal insoluble salt, and this is in contact with the solution of salt containing the same anion. Such type of electrodes are known as metal insoluble salt anion electrode, and the most common example is the calomel electrode. This is also used as a reference electrode to measure the electrode potentials of other electrodes. Now in this electrode, the metal is covered with an insoluble salt of the metal, and here the insoluble salt is mercurous chloride. So in this case, mercury is covered with the mercurous chloride paste. This is further covered by the solution of KCl, which is containing the same anion as in case of mercurous chloride. Now, how it is working, it can act as well as an anode as well as a cathode because it is a reversible electrode. So, when it is acting as anode, what happening? The mercury is releasing the 2 electron to give mercurous ion, and these mercurous ion, they react with the chloride ion to give mercurous chloride. So, overall reaction is this when it is acting as anode. And when it is acting as cathode, the mercurous ion, they are taking up the 2 electron to convert to the mercury. So this is the net reaction when it is acting as cathode. So this is the calomel electrode. Next one is the oxidation-reduction electrode. In these electrodes, how they are acting, these are prepared by dipping a platinum wire into the solution of 2 salts of same metal but in different oxidation state. Due to the different oxidation state, one ion will have tendency to convert to the other ion of different oxidation state. For example, it can act as cathode as well as anode. When it is acting as cathode, that 4 plus ion, between 4 plus ion, they are taking the 2 electron to convert to 2 plus ion. Similarly, when it is acting as anode, the 2 plus ion, the ions in 2 plus oxidation state, they are converting to the 4 plus oxidation state and releasing the 2 electron. So, in this case, potential is developed because of tendency of ions from moving to one oxidation state to the another oxidation state. Now, different type of oxidation reduction electrode on the base of organic compounds are also known. And the most simplest example is quinhydrone or quinone hydroquinone type of electrodes. In these type of electrodes, we are having an equimolar mixture of quinone and hydroquinone in the presence of H plus ion. In the presence of H plus ion, this quinone and hydroquinone, they shows a reversible oxidation reduction reaction. Quinone is taking 2 electron in the presence of H plus ion and converts to the hydroquinone. So such type of electrode are prepared by dipping the platinum strip in the saturated solution of quinhydrone at a certain hydrogen ion concentration. Where quinhydrone is what? It is an equimolar mixture of quinone and hydroquinone. So when it is acting as cathode, the quinone will be converting to hydroquinone. And when it is acting as anode, the hydroquinone will be converted to the quinone. So this is all about the different type of electrodes which are acting as a reversible electrodes. In the next chapter, next lecture, we will continue with the next topic. Thank you.